So good afternoon, everyone. My name is Rob Romanowski. I'm the Director of Sales Operations for 3HTI, and I'm very excited about today's webinar topic, Creo Flow Analysis. And leading the presentation today is going to be Paul Dye, fresh off of the PTC user trip down in Orlando, Florida, where he spent some time with our principal, Gary Hoffman, going on some rides and doing some other fun things. So Paul, good to have you. Paul is a solutions consultant for PTC and an applications engineer with the Virtual Center of Excellence. And the reason I'm so excited about Creo Flow Analysis is because there's not a lot of good CFD tools on the market today in regards to being directed for use by an engineer or a designer. And the whole idea behind this, the Creo analysis series that we've been doing is to showcase these tools that designers and engineers can use so that you can get a better read for your part, your product early in the design stage, so you don't have to make changes as it goes downstream. Now, typically with CFD, these are very complex tools that an analyst will run downstream for you. And then all of a sudden, after that's done, now you got to go back to the drawing board and change your mistakes or make your part more functionable. So the flow analysis tool helps to avoid that process that could delay you weeks at a time. This helps you to get ideas done quicker. This helps you to shorten your product development cycle, save money, save time, reduce prototypes, eliminate prototypes. There's a lot of benefits to Creo Flow. And like I said, there's not a lot of good tools on the market. And what's great about Creo Flow analysis is that there's 3 different versions based on what you need. So you don't have to pay more for the product if you don't need those particular capabilities. So we're going to have Paul review that today. And Paul, with that, take it away, man. I'm excited about this.
Awesome. Yeah, thank you very much, Rob, for having me on. And thank you, everybody, for jumping on to talk about Creo Flow Analysis. And I don't say this lightly, that probably flow analysis might be one of the best, if not the best extension that we have in Creo, especially in the realm of simulation. It's really, really powerful tool. And like Rob mentioned, I was just down at this PTC user event down in Orlando this last weekend. And we actually ran some different workshops around flow analysis, and we had a lot of people get their hands on the tool, and everybody was shocked how powerful it was, at the same time easy to use. So I'll be able to go through and explain how all of this works, and you're definitely in good hands with 3HTI. They are one of the best at really assisting with getting people up off the ground and running with flow analysis. So for my sake, I'll go through and explain a little bit about how we position, how we use this tool, and some of the real challenges that this looks to address. And it's a couple of things that Rob mentioned, right? So looking at flow analysis in general, or CFD, whatever you want to call it, is just typically seen as something that would normally require pretty extensive training or knowledge that your engineers or designers in general tend to lack, right? It's something that we're very good at designing the parts, we're good at designing the assemblies, but whenever it's time to validate them, whenever it's time to understand how they might react under real world conditions, we send it off to an expert analyst, right? Even to run this type of analysis typically requires either shipping it out to a third-party tool, which is more than often very expensive, but at the same time also hard to use, right? It's because you have to take your models from your CAD environment, you have to export them out, you have to have somebody that has knowledge on how to use fluid dynamics to even begin into an analysis. It becomes a very time-consuming process from start to finish, which tends to make the process really only viable in the later stages of the design process. And that's really because whenever you're in your development stages, whenever you're concepting, even whenever you're in the mid-stage of your designs, your models are constantly changing, right? And you just don't have time to wait around for analysis results to come back. And it leads to an over-reliance on things like physical prototyping and testing, because you do need a way to verify your designs. And that, again, still occurs later in the development cycle, can be very costly if you have to go through multiple iterations. And we see projects all the time becoming in delayed, coming in over budget, things that we want to be able to avoid overall. So these are all challenges that we look to set out to solve with our Creo Flow analysis extension. So the goal of this extension is to take all those fluid dynamic capabilities, put them into an easy to use tool right within the CAD environment, get rid of the reliance on late stage prototypes or other types of verification techniques, and build this into your early stage design process. And we want to get those results back while we're going through and building out the design. And though this is a higher end package, it's really top notch in terms of the capabilities that it provides. The main idea with this, though, is that it's still built out in a way that works for your everyday Creo user, Creo designer, right? Same user interface, very user friendly. We want both analysts and just your standard Creo users to be able to work with this extension and build this into part of the overall design process. And really the workflow between design and CFD in Creo is completely seamless compared to your normal process that you might see of having to work with a third-party system where you might have issues switching between your CAD and your analysis environments. We're really looking to break down that barrier between those two different worlds and work more in what we call an analysis-driven design environment and keep it all unified, right? We don't have to export out to be able to do that. I'll go through and show how this all works, but from the start, it's a very easy flow model creation. So you have the ability to tell the system to automatically generate the mesh. You don't have to go through and define all of that yourself. You still do have the ability to make, for example, the mesh and the flow more defined in areas where you might have want to have more control, but you could also just let Creo do a lot of that work for you as well. All right, and still, even though we have all that level of control, the results that we're getting back are just so much faster than what you'd see out in industry, right? Just the speed of what we're able to get results back in is not really matched, right? You don't have to send off models to get results back sometimes in a day or even a week later, right? We can just keep the analysis to ourselves, run through that right from within the context of Creo and get those results back in a much more timely fashion, right? So it allows us to go through and see how our models are reacting. And then based upon that, we can go right back into our design environment and make changes. And the big thing to mention there as well is that even though we're getting results back very quickly, they're still at the highest accuracy, right? We have many different ways of getting results back, taking section views of the models, getting XY plots, ISO surfaces. I'm going to go through and show what all that looks like, right? So also, one thing that we mentioned is the fact that this comes in a few different flavors depending on the level of detail or the different options that you might require for what your team works with, right? If you're just focused on looking at the flow, looking at heat transfer, looking at turbulence, which are really a lot of the main capabilities that we look to analyze from within the context of our systems, that's all included just within the base of flow analysis. This is going to be very good for a lot of different Creo designers, but we also have a lot more options around this as well. If you want to analyze elements like individual particles or radiation, you might want to move up to the Plus package. This also gives the ability to simulate the movement of individual components. You can also animate on the analysis even while it's running. So a few more options that you're going to get access to once you move up to the second option here. And then we do have more of a premium option if you're working with dynamic models, multi-phase, multi-component systems. You're going to want to utilize this package, right? You get so many more options for cavitation, simulating fluids and solids interacting. It's really the complete fluid analysis solution that would work all the way up through what your highest end analysis or even experts would want to be utilizing throughout this. And I can leave up just on the screen here for a moment, and we'll touch back on this after the demonstration, but you can get kind of a overview look here as well with some of the different options in terms of what you're working with at flow analysis. Again, as you're moving up into more capabilities, you're still going to maintain all the capabilities that came in the packages before. So again, this is an extremely strong tool. And one thing I'll mention as well is that we built out this tool through one of our partners, Simerix. They provide and always update the engine that we're working with in flow analysis. It's something that is constantly getting improvements, constantly getting updated, and just getting more and more capabilities every single release of Creo. So that's Simerix partner. They also have a lot of examples over on their website they could go through and check out to see what we've done with Creo Flow analysis, some of the different examples that we've built into, but really gonna fit into almost all use cases that you could potentially think of. All right, and before I jump into the demonstration, if anyone has any questions or anything before that, you can go ahead and take that now.
No questions at this time, and if anybody has any, you can just feel free to type those into the Q&A box or the chat box. Either way, we will answer them.
Yep. All right, So with that, I'll go ahead and jump into a demonstration so we can see what this looks like. So in my case here, we're going to be working with this Polaris snowmobile data set. A little bit more specifically, we want to get some information on a heat exchanger that we have working inside here. You can see this part that we're going to be working with. And we have some pretty good geometry that we're going to be able to utilize, right? I know that I'm going to have water moving through this heat exchanger, so we can go ahead through the process of setting this up. Right, first step that you're going to do whenever you get into any flow analysis study is just go right up to the applications and select it right up from the top, right? And from here, we would essentially just say, hey, we want to start into a new project. And then we'll go ahead and lay out the basic boundary conditions and domains for the study. So a fluid domain is essentially going to be our boundary for the simulation. Just means that all the fluids that we're looking at in the study are going to be contained within a certain 3D space. The other thing that we'll do within this process is lay out the openings and the exits, so just wherever fluid is either entering or leaving the system. And after we lay out the fluid domain, there's obviously parts of the model where fluid's not going to be moving through. So here we can just tell the system which parts of the model should be treated as solids and then excluded from the fluid study. And then from there, we're able to define the types of materials that we want to look at, right? Obviously, things are going to change depending on what we lay out here. So we have a lot of options when it comes to our fluid domains, for example. You can see right now I have selected as air, but we have tons of different options that you can select from. And you could also add your own fluids in there as well if there was any that weren't within that catalog. And same thing with solid domains, you could add your own, but we have the full Creo material library to work with that you can go through and apply to the model. In our case, it's going to be an aluminum alloy. Next thing I could take a look at here is the different physics modules that we want to run for a particular study. So for our study, we're interested in analyzing turbulent properties. We also want to see some heat and streamlines. You can essentially go through and determine exactly what you want to focus on, so you don't have to waste time calculating species or particle flow if you're not interested in those. We can really nail down exactly what we want to be looking at there. Right, once we have that defined, we can take a closer look into some of the conditions for our analysis. So for our study here, maybe we're interested in seeing what the minimum and maximum temperature values are going to be. We also have some options to plot out those outputs, which we'll see more of in a minute. But the next spot I want to take a closer look into is our boundary conditions. Go ahead and zoom in up here on our inlet pipe, go through and enter in some of the values that we want to observe. If we're interested in the inlet flux, if we're interested in the temperature, we can go ahead and lay those out. There's a ton of different parameters that you could go through and change here, just really tailoring the analysis to the exact use case that you want to study. Same thing down here on the outlet. In my case, I'm pretty much happy with some of the different values that I have laid out down here. And once we have that all added in, we can go ahead and define the mesh for our fluid flow analysis. Again, Creo's able to automatically build out that mesh for the model. We can just simply say, hey, go ahead and generate that, and we can open up the grid and make sure that everything looks the way that we want it to. Go ahead and generate that mesh very quickly. And we can also take a step back in here and look at if we'd like to. And with this automatic meshing, you'll see that it uses a pretty standard way of doing this, right? So you can see in some of the areas where there's a little bit less complexity or a little bit less curvature, it's going to expand that mesh out. And then in any areas that you're particularly interested in, or any areas that might be of a little bit higher complexity, you can go ahead and make that mesh a bit finer to get better results back in those areas. All right, and with that all laid out, we're pretty much good to go ahead and jump into the study. And with that, we can go ahead and see our plots and go ahead and click to run. And essentially, as soon as I click the button to run that simulation, we're immediately getting data back from the study. I'm able to go through and change the animation style, just put it into a form that best displays the information that I'm interested in. We can see down there at our plots at the bottom, we see our maximum temperature settling out just at around 360 degrees Kelvin. And for each iteration that we go through, our plot information is going to be updated real time. So again, we're really getting back results that fast. It took us about 3 minutes to set everything up, and we can go through and see what we're getting back from the study. And once we completed the analysis, we can go through and see what we got going on here. You see the water's coming into the heat exchanger at the highest temperature. And as it's moving through, it's cooling down by the time it gets to the outlet. So at least from a functional perspective, seems to be working as I intended. We can go through and look at some other outputs like pressure, see how that's changing over the course of the flow. Maybe we also need to see the effect on the temperature of the outer casing of the heat exchanger as a result of that flow. So it just gives us better insight, gives us a better understanding of what's really happening in this process. And one other very useful tool that we have throughout this is the ability to take section views of the results that we're getting back. So say, for example, we wanted to look at some of the temperature values inside of the model. We can move that to the X plane, move it around to the Y, move it to the Z, drag that around throughout the model. And another thing that we have at our disposal throughout this is the ability to search for specific values in the simulation. So first, what we have is a slider bar that we can move from a minimum to a maximum to see exactly where those values are located. Also, if you wanted to see everywhere that you're getting a particular temperature value, you could also type that in and see right where that's occurring on the model. All right, so oftentimes what's going to happen in this process is you probably need to make changes. Maybe someone from your team sends over a newer version of the model that you've been working on, because like I mentioned, we're likely going to be using this tool throughout the development process. So you can see this one here has a little bit more of a lattice type structure. It's definitely going to change how that heat exchange is going to work. But instead of having to go through and set up an entirely new study, we could simply just open up and utilize the one that we had created from before. So first thing we'll do is update the study to recognize some of that new geometry that got added in. This will be some solids that we want to recognize. And we'll also update our surface sets to include the faces around the inlet and outlet there. All right, so finally we can go ahead and hide those CAD bodies. We'll utilize the mesh and the plots that we have set up, and we can go ahead and run through that analysis. All right, and you can see, again, essentially, as soon as we click to run the analysis, we're instantly going to be getting back meaningful data. And again, we can change any of the properties to get our flow into a form that makes the most sense for us. And looking at the flow animation there on the model, we can see that the lattices definitely changed how we're directing the flow, right? How it's being spread out across the part here. So maybe our heat exchanger is working a little bit better than it was before. And from the plot information as well, as we go through more iterations, we're beginning to converge towards more accurate values for things like pressure, temperature, velocity. And once that simulation is complete, we can go through and observe the flow a little bit closer. We can click through to see any of the properties that we're concerned with, go back and see what it's looking like throughout the model for our pressure. Do the same thing for the outer casing as well. In this case here, it seems like that those temperature values were more evenly spread out across the model there. So definitely working in the right direction. All right, so that really covers everything that I wanted to touch on. There's definitely a lot of value that goes into that, a lot of main capabilities that we really get from that process as well, right? In terms of value, you can see that we're really working towards more of an analysis-driven design, right? That's the main goal of this at the end of the day. We're running these studies earlier in the design process. We're really breaking our dependence on things like late-stage physical prototypes. It's reducing a ton of costs and time to market, right? That's just due to the fact that we can go through more iterations earlier in the process. You don't have to save them all to the end. And what it really boils down to is you're creating and innovating at every stage of the design process. It's something that we can go through and really, at the end of the day, get a lot higher quality parts out of. And with that, I'll go ahead and pull this back to our packaging slide very quickly, just so you can see, and I can leave it up on here while we're wrapping up. But yeah, again, very powerful tool. There's so many things that I can't even touch on just for a general overview, but definitely something that if you're working with Flow in the context of Creo, this is a no-brainer to be working with.
Good stuff, Paul. This is fantastic. Like I said, I was very excited about this because we have a CFD expert on staff. His name is Bill Stickney, and he's worked with NASA. He's worked with a lot of the national laboratories, a lot of government and military departments. He really knows his stuff. And when Creo Flow first came out, I think it might have been back in 2014 or 15, he said, "This is interesting, but I don't think it's ready yet." And I remember about 3 years ago, Bill saying to me, "Wow, they've made a lot of updates to Creo Flow, and this thing is really good. Like, this is a really good package." So we're not the kind of We're not the kind of company that just wants to sell software just for the sake of selling it. It's got to be useful. It's got to be able to solve a problem, and your people have to be able to use it. They have to be proficient at it if you're going to purchase it. And that's where we step up our game as a reseller to bring that value add of getting your people up and running and being proficiently quickly so they can use the software, so you can see a return on the investment and that you reap those benefits. And once again, looking at this package overview, based on what you need to accomplish, you may not need the premium package. So there's definitely some cost savings there. Now, I believe that these packages are on special for with PTC for this quarter. So if you're interested in getting a price quote for the special for this quarter, just email me. Respond to the email that I sent for you to register for the webinar. Those emails come back to me, and I could just let you quickly know what the price is until the end of December for Creo Flow as well as other Creo extensions. So Paul, thanks a lot for leading us today, and that's going to end our webinar. And we look forward to seeing everybody next week. Thank you for attending, and have a great weekend. Take care, everyone.